There are places in our solar system where the sun is not a giver of life, but merely the brightest star in a sky of eternal night. Here, 3 billion miles from Earth, the laws of biology as we know them cease to apply. This is the Kuiper Belt, the twilight zone of our star's influence. It is a graveyard of planetary formation, a ring of frozen debris left over from the birth of the solar system. For decades, we believed this world was a fossil, a sphere of rock and nitrogen ice, frozen solid since the dawn of time. The surface temperature hovers around 40 Kelvin, minus 230 degrees Celsius. At these temperatures, nitrogen, the gas you are breathing right now, turns into a solid brittle enough to shatter like glass. Logic dictates that Pluto should be dead, but the universe has a habit of defying our logic. Because inside this frozen dwarf, beneath a crust of ice harder than granite, something impossible is hiding. Something that challenges our very definition of what a habitable world can be. In 2015, humanity finally knocked on Pluto's door. The New Horizons spacecraft, moving at over 30,000 miles per hour, swept past the dwarf planet. It had only hours to gather data, but what it sent back rewrote the textbooks. This is Sputnik Planitia, the left ventricle of Pluto's heart. Look closely. Do you see craters? There are none. In a solar system pummeled by asteroids for 4 billion years, a crater-free surface means only one thing: youth. This surface is being refreshed. It is being paved over. But for a skin to move, it must be lubricated. For a planet to be active, it needs a heart that is still beating. Gravitational data tells us that Sputnik Planitia is heavy, suspiciously heavy. Something dense is pulling from beneath that basin. The math leads to an inescapable conclusion. To balance the weight of this world, there must be a layer between the rock and the ice that is denser than the crust, but fluid enough to allow the shell to slide. There is an ocean inside Pluto. Let us pause to appreciate how strange this is. We are talking about a global ocean, potentially 100 kilometers deep, that is 10 times deeper than the Marianas Trench. But how? How can a world so far from the sun, a world that receives 1/900th of the sunlight that Earth does, maintain liquid water? By all rights, Pluto should be a solid ice cube. Any water should have frozen into a type of ice, so hard it mimics the physics of rock. To solve this mystery, we must look at two things: the engine and the antifreeze. First, the engine. Deep inside Pluto lies a core of silicate rock. It is not molten like Earth's core, but it is radioactive. Elements like uranium-238, thorium-232, and potassium-40 are unstable. As they decay, they release heat. It is a slow, agonizing burn, a faint candle in the dark. This is radiogenic heating. On its own, it is barely enough to keep a cup of coffee warm, let alone a planetary ocean. If this water were pure, the radioactive heat would not be enough. The ocean would freeze from the top down, eventually seizing up the entire planet. But Pluto's ocean is not pure water. It is a chemical brew. Enter ammonia. We find ammonia everywhere in the outer solar system. It is a building block of comets and dwarf planets, and it possesses a magical property. When you mix ammonia with water, you disrupt the hydrogen bonds that allow ice to form. An ammonia-water mixture can remain liquid down to minus 100 degrees Celsius. It acts as a cosmic antifreeze. This ammoniated ocean would be strange to behold. It would be incredibly salty, rich in organic salts, and viscous, perhaps the consistency of syrup or chilled honey. Furthermore, recent models suggest that the base of Pluto's ice shell contains gas hydrates, cages of ice trapping methane gas. This acts as a thermal blanket, a planetary insulator that keeps the faint heat of the core locked inside, simmering the ammonia-rich slurry for billions of years. It is a perfect storm of physics and chemistry. A radioactive heart, a thermal blanket, and chemical antifreeze. Nature, it seems, goes to great lengths to keep water liquid. The existence of this ocean changes everything. For centuries, we search for the Goldilocks zone, that narrow band around a star where it's not too hot and not too cold. We thought life could only exist where sunlight kisses the surface. But Pluto has taught us that the Goldilocks zone is a relic of limited imagination. If a tiny world, relegated to the frozen fringes of the solar system, can harbor a liquid ocean, then oceans may be the rule. not the exception. There are billions of dwarf planets, icy moons, and rogue worlds drifting in the dark. If they have rock, and they have ammonia, they could have oceans. We used to look at Pluto and see a dead rock at the edge of the map. Now, we look at it and see a reservoir of possibility. We see a world that has kept its heart warm for 4.5 billion years, waiting for us to understand. Water, it seems, is stubborn. And where there is water, we dare to hope there may be more.